Slide this over a little. All right. Howdy, everybody. Let's see if started getting a little bit of a late start here. Sorry, there was a little seminar over in Castle, and it's a bit of a walk. So I know I've got trees on the schedule today, but we might not get to them yet. I want to spend a little bit of time talking about the lab from Stacks, Queues, and Decks. Got a lot of questions about that one. And then the lab today about linked lists. Again, more questions about that one. And then we need to talk about our next project, which is going to be based on stacks and queues. So I want to make sure we cover the lab first so you get a good feel for what was going on with stacks and queues, because we're going to use even more of them when we do the project assignment using stacks and queues. And then probably on Thursday, then we'll get to trees. And again, we don't need to go super deep on trees, because this you'll pick up more in the data structures algorithm analysis class. We want to get a base level understanding for trees. And then if it needs to, the trees are actually used in priority queues. So, if a little bit needs to push till Tuesday, that should be perfectly fine. We'll get to doing our own maps and hash tables. We skip mostly out of skip lists. That's one of the more advanced topics. We'll mention them, and that's about as far as we get with skip lists. We'll get to search trees, which is a particular type of tree as well. A little bit on sorting and selection, and then ethics, and working on the final project. So we'll do project 2, right, these 2 weeks here, and then we'll do project 3, these 2 weeks here, and we'll have the final project for all of April. That's the goal. And again, our presentations we can just do on Zoom, so you guys can all take turns doing screen sharing. We'll probably need to start about 4 p.m. or so. I've got something going at like 2:30 that might keep me a little bit late that I can't unfortunately reschedule at the moment, but that should still be plenty of time for us to do those final presentations. So we've got 2 more big projects that we're working on, all the labs we're practicing, and then the final project, again, which makes up the bulk of your grade here. So it's worth just as much as the individual projects altogether, so we'll focus on that. All right, so let's talk about the lab first. Let me fire up PyCharm here. Maybe PyCharm. PyCharm. This search has gotten super weird with Windows 11. This was the stacks and queues lab, so we're going to have this depot essentially where we're unloading our ship, and we're going to put stuff into a queue of stacks for our trains, and then just a general queue for the planes, right? And then see how long it takes to get each one of those loaded. We haven't got to the point of trying to optimize anything yet. This is just, hey, let's follow this approach to see what we can do. When we do our project, we're going to look at what we can do to optimize things that use stacks and queues. So should be interesting. It's generally been a lot of fun to work on that one, so we'll see how well this goes. We fire up a new project here then. Maybe. I had to fire up PyCharm to help me with my Wordle the other day. Well, I've said it was cheating, but I could do it by hand on paper, so I figured this is just doing it faster. So turns out there were a couple foreign words here. So all right, so let's do that lab project first. I wasn't even using a word list comparator. I was just simply to print out the permutations. That was it. Definitely not cheating. If I wanted to cheat, we'd just look at the JavaScript in Wordle. So this was purely a helper. All right. So for that lab, we were doing this loading and unloading scenario. Right. So we had a bunch of values coming in. We had the number of trains, number of planes, number of items for trains, number of items for planes, the item number of items for each train, number of items for each plane, and then the actual items themselves that get unloaded. All sorts of fun input here. So we had lots of different ways of going about dealing with our input. Had lots of different choices for how I want to do this. And then thinking about how we want to track these sorts of load times. So there's definitely more than one way to solve the problem. I'm going to approach it in an object-oriented manner, because I think that's a nice way for us to think about it and use some of the tools and techniques and things that we've learned. Not necessary at all, definitely not needed, but I think it will make the solution a little simpler and a little easier to follow, rather than here's one big, long, okay, give me some input, throw a bunch of things into stacks and queues and spit it back out. Again, the goal of good programming is so that when you're done, you can come back to it later and know what's happening, right? Without having to spend too much time going about it here, right? We're writing the code for people, for us to look at later, and then our team, whoever's going to come after us and have to maintain our software after us as well. So it's not just about, can I get the fastest solution? Can I do this in 15 lines? Maybe we could do it in like 25 lines. Probably don't want to do this in 25 lines because we'll have no idea what it is the next day. That's not necessarily the goal here. So what we want to do is essentially break this out into those nouns. And as we're looking at a problem, we want to identify what are the possible nouns here that could become classes. Well, and so you've got train, you've got plane. Right? Those ones definitely could be possible nouns here. We have the dock, which things are put onto, right? It's staged, that we have all the plane items, we have all the train items on this dock. And then we have the workers. We'll see, probably don't need a worker class itself. Maybe we do, maybe we don't. But just looking at the nouns, right? So if we do that, then we could write a class for the dock. Oops, and a colon there. And what does the dock have? Well, when you initialize the dock, right, you need to tell it a couple things. You need to give it a bunch of numbers, right? We could give it the number of planes, we could give it the number of trains, we could give it the train items, the plane items, these sorts of things here. These two numbers here are not actually all that interesting for us unless we really care about doing some sort of validation, right? Because the 10 here is just going to be the sum of these numbers here, or literally the count of these ones here. So unless we want to validate we're getting good input, we don't actually care about these ones here because we can get those values elsewhere, right? They're not all that important to us. So really, I care about how many planes and how many trains. So, and those are really how many items I'm getting down here and how many items I'm getting down here. So this entire first line, we don't really need to do anything with unless we want to do some extra validation, which there's nothing wrong with that. But for our simplicity's sake, let's just ignore it. We don't really care. What we care about is number of items per train and number of items per plane, and then we care about the train items and we care about the plane items. So these are the four important lines that we need. We can derive this information from the other four if we wanted it. Okay, so when we create a dock, then I need to know the items per train. I need to know the items per plane. I need to know the train items, and I need to know the plane items. Right? If I give you those four pieces of information, essentially those four lines here, and if we just pass them as a string for now, that's perfectly fine. We'll just ask for some input, and then we'll feed it right on through. There's all sorts of ways to deal with input, but for now, this is probably pretty straightforward. We just give them, here's the first line, or actually the second line, the third line, the fourth line, the fifth line. We'll skip line 1 because we don't care. But sure, we can pass that information here. Then what we can do with that is we can make a list of planes and a list of trains. Right? Now, we had mentioned planes and trains are possible classes. Right? So we could have a class for plane and a class for train. Now, before we go do that, what attributes does a train have? What attributes does a plane have? Well, they have the number of items that they're supposed to have, and they have the time that they're full, and then they have essentially how long it takes to load, which is just like a factor of its position. But it's a factor of position, so it's like a multiple there. So a train is no different than a plane, aside from it takes 5 times the plane number to get there. A train takes 1 times the train number to get there. So when we're thinking of what is similar and what is different, if it's just one attribute, I don't need separate classes. So we can just have a class for like transport method. Sure, why not? And then this then can have an init method that takes the number of items until full, right? And it could take the time factor. That's a bit of a stretch here, but like if I say, hey, take this to train number 2, I'm going to take 2 times the time factor. If I say take it to plane number 2, I'm going to take it to 2 times the time factor For planes, the time factor is 5. For trains, the time factor is 1. So this time factor for, I don't know, is that enough? I want to say more things, but then it's going to be like an entire paragraph, right? So time factor, hopefully that makes sense, what we're meaning for that. So that one's a bit of a stretch there, I apologize. But then we'll have our self.number of items until full is equal to the number of items until full, and a self.time factor. Now, again, private values are good practice here, right? We don't want other people to be changing these things after we make them here. So we'll make them private. But then to get those values back out, we need a method like get time factor, right? That returns the self time factor, because we need to know that. We need that for our calculations. Possibly, and we'll see. Maybe we'll come back to that. Maybe we need it here. So what do we do with transport methods? Right? These are attributes of transport methods. What do we do with them? Well, we need to load items on them, right? So we need a method here, a way to interact with it, which is load an item. So to load an item, then, we need to be counting how many items we currently have. So we need another value, a self dot, that says current items, or current item count, maybe? How about that? That one starts off at 0. When we load an item, let's increase it by 1, right? Sure, we'll load an item, plus equals 1. Now, we have the time factor here, so what we probably need is the time started, right? And then we also need a value for time when fully loaded, right? We need to be, that's the ultimate goal of what we're tracking with these things, is when they were fully loaded. So we can have a self time until fully loaded. I'm just going to start off at 0, because until we know otherwise, we don't know. So we can check. We can say, okay, we'll add an item, we'll load the item, right? If my self dot current item count is equal to the self dot number of items until full, I'm full, I can track my time. So my time until fully loaded, right, becomes my, this is not really time started, so we need the time started plus my time factor, right? And we probably need to know what position we're in as well. So, right, if we're saying, hey, this is train number 2 or train number 3 or train number 4 or train number 5, we'll take that into account with our time factor, perhaps. So a couple ways of going about that. We could just say, hey, train number 1's time factor is 1, plane number 1's time factor is 5, train number 2's time factor is 2, plane number 2's time factor is 10, because it takes 10 minutes to get there. So maybe this is time, what we call it, instead of time factor, this is time to reach from dock. How about that? So we just say, hey, how much time does it take to get here from the dock? And we can tell that transport method when we create it. So the time until fully loaded then is going to be the time started plus the time to reach from dock, right? So if I'm going to load something, and hey, I'm loading it on train number 7. I've told the train number 7 the time to reach it from the dock is 7 minutes, because that's 7 minutes for a one-way trip. If that's its last item, I'll take the time that I started. So hey, worker started loading you at this time. Okay, great. And loaded my last item. I'll take my fully loaded time, given the time that it took to get from the dock. Now I know how much time it is. I know when I was fully loaded. If it's not fully loaded, we don't care. There's nothing else to do here. What we're going to do then is we're going to return our time started plus 2 times the time to reach from dock. Time to reach from the dock. So we'll return the time that we returned back to the dock. So we give it what time we left the dock, and we're returning what time we got back from the dock. So the transport method can help us calculate this because it knows how long it takes to get there and back. So it's one way, because you could keep this information elsewhere, but it works well, I think, being part of the transport method. You tell it, hey, this is how long it takes to get to you. We don't necessarily have to be tracking it here, but it's going to be nice because otherwise we have to tell it when we load the item what time we would get there with an item. and then we're tracking it on our side. Maybe we could do that too. So time, we could do either approach. Maybe we'll do that. So we'll have the time worker arrived then. So we'll forget this here then. So we don't need to track any of this. So it just cares whether or not it's full. How about that? So if we're full, then we'll take that time the worker arrived. And that's it. That's all we're going to do then for load item. We'll keep it simple. So this is what our transport method does. It just tracks how many items it has, and it will tell me when it's fully loaded. So we need a way to get this time back out then, right? Because we're going to ask our transport methods, hey, when were you fully loaded? So get time until fully loaded, or time, I guess time until fully loaded, makes sense? And we'll return that value. So if we reach our max items, we'll take the time that the worker arrived. So we'll let the doc figure out the time, I guess. That one's a little ambiguous as to where we want to track the time. Right? It doesn't really, it's not really an attribute of an object. It's something we're tracking on the side. So maybe it's fine to leave out of the class. There's lots of ways to go about it. Not one wrong way. Okay. So then if we have these transport methods, then that they just need to know how many items they have until they're full, we can make a list of them here in doc, right? So we'll have a self.trains is going to be a list. And for every item per train, we can go add a new transport method, a train here, to our trains list, right? So I can say for value in my items per train, and we want to split that on a space. So split, right, is going to take a string and split it. The default split is on spaces here. So that is each value, right? And items per train. Sure. I think value is fine here. I don't know if we want to call it anything better. But we're going to take self.trains, and we're going to append a transport method given the integer of the value. Right? Turn that value into an integer, because this was a numeric value, but as a string, it's just a string character. We need it as an integer, so I can do that integer arithmetic. Hey, did we reach this number? And I can add +1, +1, +1, +1, right, to it. So it has to be an integer. Now, I'm going to cheat just a little bit here, and I'm going to put a none inside my list here, so that index 0 is none, and then trains are at 1 through n trains. Does that make sense? Because that way, train number 1 is at index 1 of self-trains. Train number 2 is at index of self-trains index 2. Otherwise, I have to account for index and offset, those sorts of things. It's going to make my life easier when I take my train items and say, hey, what train item are you? Oh, you're a number 5? You go to index 5. Rather than, oh, you go to 5, that's index 5 minus 1. So this is just helping me here, to actually get indexes at the values rather than being 0-based. So just a little shortcut, and it adds one more memory address. So in terms of performance-wise, we barely are ever going to notice at all. We'll just add one none. Right, and we're going to do the same for trains. So self.trains, or planes, I'm sorry, is going to start off with a none here, and then for value in, this is items per plane split. We'll take our planes and we'll append a transport method given the value. Right, this is how many items you need, right? The items until you're full. So we've dealt with the first two items. So we have our list of trains and we have our list of planes, and they each know how many items they take. Right, now we need to deal with our train items and our plane items. So we want a self.train items. Now remember, the train items was going to be a queue of stacks here. So if we want, we can go take the queue class and the stack class, which is probably the right thing to do, and go paste them in here. So we can use a queue and we can use a stack properly. We could also just use a list and only use the right operations if we wanted to, if we trusted ourselves to do the right thing. But it's not bad to go copy paste a little queue of stacks here. It's the wrong semester. Or yeah, there we go, 2022. So we'll go find our queue and our stacks here. So that was in our week 5 stacks and queues. We had some classes in here. I think this stack was fine, right? So we can just take class for stack here, throw this one in. And we should be good about it and say, hey, this is where I got it from, right? So you can even like highlight these line numbers if you want to be super fancy. I know, not that particular here. Right, got it from there. And then our Q then, we had a couple different versions of Q. Right, we want the one that is most performant. So resize was N, but everything else was fast on our circular Q. So we said this was fine. Right? We weren't going to have to resize often enough for it to really matter too much. Yeah, the circular Q I think was the easy one, GG hockey. So we'll take the circular Q. And it doesn't, for our purposes, doesn't matter much. Even if we throw 1,000 things here, it's still going to be super fast, right? But if we're talking about like millions of items, then these things will really start adding up. Thankfully, we're not going to be unloading millions of items because that would just be nuts. Again, you can put them all in one file. You can put them in separate files if you want, whatever you prefer. I think one file might be easiest for now for the lab. I don't know. We could put them in separate and do a bunch of imports, but not too concerned one way or the other. And then again, we'll cite our source here. We got this one from here. Circular Q right here. Sure. And put a little comment in. So then our train items was going to be a queue. Inside of that queue, we're going to put a bunch of stacks. So we want a queue, or I'm sorry, a circular queue here. And then we had a, now we need to go figure out what to do with these things, right? So we're going to do make a stack, put up to 5 things in it, put it in the queue. If we have more things, make a stack, put up to 5 things in it, put it in the queue, right? So we're going to start with a stack. So this is a, we don't even need a self value here. This is just a current stack equals a stack. And then we're going to say for what this is train, I don't know, this item in train items dot split. The first thing we need to do is turn that into an integer. So item equals an int of item. Backwards here, right? Other direction. Right? So turn it into an integer. Now I have the integer value of where this train item is going to go. Right? Let's add it to the stack. So we'll take our current stack and let's push the item. And then we're going to say, hey, if my current stack, I'm sorry, the length of current stack, if length of current stack is equal to 5, let's take the stack and put it in the queue. Now we have a full stack, put it in the queue. Take our self.train items, train items. We want to enqueue the current stack. If we're enqueuing the current stack, we need to have a brand new stack after the fact. Right? If we had 5 items, put it in. Right? Then make a new stack to start the next set of 5 items, or more, 5 or less, right? So work through all the items, put them into the stack if our stack reaches our max height here. And again, having this value here is a little bit ugly, so we might even want to consider having something like max train item, I don't know, train stack size. It's 5. Size, there we go. And I can use that value here then instead. Be a little prettier here. Self dot. Right? So use like a constant sort of value here. Because anytime you have just like a number in there that doesn't have a name, you're probably going to forget what it is later. So they call them magic numbers. If you just see, hey, there's a number here without a name. So sure, it's a max train stack size. Okay? When this is all done here, I might not have a multiple of 5 items. What if I only had 7 items for trains? I have a current stack with some n number of items in it. I need to then also enqueue that when I'm done to make sure I get the last remaining. If there wasn't, so when we have 10 items in the example, both items will get queued because we had 10 items. Great. If we had 11 items, we never would have queued that 11th item until we get down to here. So you want to make sure you're also adding the partial stack at the end. Now, if this is empty, we don't actually care because we're going to take empty stacks off anyway. So if we queued an empty stack, it doesn't hurt anything at the end. So if there's something in it, good, we didn't lose something. And if it's empty, it doesn't hurt anything. So this is adding the last partial stack. Last possible partial stack. If we didn't a multiple of 5 items. Right? So now our train items are done. We've taken up to 5, put it in the queue. Up to 5, put it in the queue. Up to 5, put it in the queue. Whatever's left, 1, 2, 3, 4, 0, 0, 1, 2, 3, 4, put it in the queue. We've looped through every value in that string of train items. Right? Okay. Usually I would look for head nods. I'm sorry. And there's only 2 of you here, so and I can't watch Twitch. They don't head nod at me. Okay, now we need to do our plane items. Well, plane items was super easy. It's just a queue. So self.plane items is a queue. And then for item in plane items, let's take the item is an int of the item and take our self.plane items, plane items, and let's enqueue. I'm sorry. Oh, it's a circular queue is why, sorry. That's why it wasn't giving me the type of head. Plane items dot enqueue the item. That's it. They just all go on a conveyor belt. First one, first. First in, first out. Done. Not anything super crazy. Now our doc is done. So if you create an instance of doc, you tell me the items per train, items per plane. You tell me the train items and the plane items. We're done. The doc is set up. I have all the trains ready to go. I have all the planes ready to go, which are instances of our transport method class here. Let me get rid of all this garbage. We don't need any of that, right? There. I think that's better. And they want 2 lines. Sorry. Those yellow lines bother me. They're just like warnings, but they make me sad sometimes. Is that happier now? The space. There. Okay. So we're set up to go. Now we need to go load the items, right? Process all the items. So that could probably be its own method, right? I mean, we could turn any of these into methods, like set up trains, set up planes, load planes, load trains. We could break them further down if you wanted into other helper methods. This is probably okay. The general rule of thumb is if your method takes up more than a page, it's probably too big and you should break it up. Just a rule of thumb. It's not a hard and fast rule or anything, but just in terms of looking at a method in code or a function in code, if it fits on a page, it's probably good. And my font's a little large here because I'm trying to make sure it's viewable on stream. So this would definitely fit on a page, a single screen, with a regular size font. Although I have to admit, I like this as I'm getting older. It's a little easier to see. So this is probably okay. If you wanted to break it up into separate functions, that's cool too. But let's definitely have a separate function then for do the actual loading. So we'll define a function for load trains. Right? And then we'll define a function for load planes. Okay? So when we're done with all of these then, right, when we're done loading, we can call load trains, I guess it doesn't matter which order, and self.load planes. Right? And we can go do those things. So which one do you want to do first, the planes or the trains? Trains. Okay, so for trains. So we're going to say now, while we have items to work, right? So while the length of my self.train items, or do we have an is empty? I'm trying to remember here with our circular queue. Yeah, we had an is empty, so we can do that. So we can just say while not self.train items is empty. While we're not empty, we have something to do, right? And we're going to say our current time is 0, right? Current time starts at 0. While we have something to do, let's go do it. So we'll take the item is going to be the top of the front stack. Right, so first I guess we should say, so if the self.train items dot front dot is empty, so front we know is a stack, and then we can ask the stack if it's empty or not, right? Our stack class I think had an is empty. So if that stack is empty, we're going to pull it off. We can just work it while it's in the front. You could either remove it if you want and then work it, or you could leave it in the front and work it. Probably doesn't matter one way or the other. Okay, we'll save a little bit of typing here. So we'll say our current stack is equal to the self.train items, train_items.dequeue. Grab the first stack. That's our current stack. Now we can say while not current stack current stack dot is empty. Well, that one's not empty. Let's go do something. Right? Why is it not like this? Function DQ doesn't return anything. Train items. Isn't it DQ? Did we mess this up? Returns an item. Did I mess something up? Circular queue. I think it's confused. Train items is a circular queue. DQ will return something. Right? DQ. I'm super confused now. Here's a circular queue class, here's DQ. It returns item. So we're inside of our doc class. I think it's fine. I think that's just a bad warning right now, and I think it's just confused. Oh, probably because it didn't finish compiling here. Okay. Let's say pass, is it happy now? I think it's fine. We'll find out. Maybe I'm going crazy. So while we have something in that stack, we need to see where it goes, go load it, and be adding to our time. So then the current item is going to be our current stack.pop. Take the item off the top of the stack. Okay, now we have an item. Now that item tells me which train it's going to. Right? It has the number. The value of it is the number train that it's going to. I'm going to take my current time. Okay, let's say, so the arrival time is going to be the current time plus the current item. Right, is that many number of minutes. So train number 2 takes 2 minutes, train number 3 takes 3 minutes, train number 4 takes 4 minutes. So we know the arrival time. And then I can say self.trains at the index of the current item dot load item given the arrival time. Okay, we'll load the item given the time that it should arrive. So we know the arrival time because this is what we're tracking here, is just current item. Sure. Okay, and then we have the current time then will be the current time. Actually, we can just add to it, right? Plus equals the current item times 2. It takes 2 times the train number to get there and back. So now we've changed current time. So 2, this is a little bit ugly again. Maybe we want to have some sort of factor in here as a static value here. This is train round trip. Factor is 2, and then how about a plain round trip? Factor is 5. So this is a little ugly here. So maybe we just have one way time, maybe, and we leave that as 1. And plain one-way time. The time is 5. I think this is probably easier here, so I can use those values then inside of here. Times 2 times the train one-way time, self dot. Because we know this is one way, so we're doubling the one way, right? Plus this current time times the train one-way time. Does that make sense? It's not doing anything here. We're multiplying by 1, but now we have this value in case it wants to change later. We don't have anything magic. And the 2 here is because it's 2 trips. Right? This is the round trip time. So maybe we can make this a little cleaner here, but I think that's probably fine. So while we have something, grab it, go load it. 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 When it's empty, this loop stops here, right? And then we go back to our next loop. If the queue is not empty, grab the next stack. Well, that stack's not empty, go load it. When that stack's empty, come back. If there's more, grab it. When this one's empty, the loop stops. That's it for load train. Right? All of the time tracking happens here, and the load item is telling it, hey, we loaded an item, here's what time it arrived, you can track when you're full. So we've said the train itself should know what time it's full if we're telling it what time the item arrives. And that's part of the trade-off. We have to be giving it that information of what time we arrived. We could have otherwise tracked it separately, told it what the current time was. It could have tracked some of that stuff. Oh yeah, thanks, Sayakon. I think that unfinished function is probably throwing it off. It probably is. It's just confused. Okay, so that's it for trains. When we're done, we'll have an empty train item stack. The planes then is pretty similar. We'll take a current time is 0, right? And then we'll say while the not self.train plane items is empty, while we have items to load, let's go load them. Now this one is pretty quick. We just say, hey, let's take our self.planes at the index of the front item. I guess we should keep the item current item. Current item is my plane items dot DQ, right? Take the thing off the queue. Then let's go add it. So our self dot planes at index of current item dot load item. Now we need the arrival time. Sorry, the arrival time. So arrival time is going to be the current time plus the current item times the self.plane one-way time. Plane one-way time. Right, whatever time it is now, plus the item times the train one. So for plane 1, it will take 5 times that. For plane 2, it'll take 5 times that. For plane 3, it'll take 5 times that. So we'll load the item given the arrival time. And then we'll take our current time plus equals the current, the current item, times 2 times the plane one-way time. That make sense? I'm feeling this just seems a little ugly here, but I'm sure that's fine. We could probably clean this up, but it's okay. And that's it. That's all we do to load. Grab the item, load it. Grab the item, load it. Grab the item, load it. And it keeps track of time for us with this current time changing every time. Right? It'll go back and grab the next item, grab the next item, grab the next item. So the last thing we can do then for doc is we can have if we wanted here, this string method, so we can just print the doc out. I don't know if that's necessarily what we want here. But we want a way to be able to get this output back out. Right? The goal was an output of how long did it take to load these things. So how about we have a function for print train fully loaded times? How about that? Train fully loaded times. Oh my goodness. And we're going to just print a bunch of things. So we'll say for item in self.train items, or self.trains. And really, we don't want to loop this way because we know the first one was none. So we want to cheat a little bit. We want to say for index in range 1 to the length of self.train items, self.trains. Right, now we can go get them out by index. So if I had 3 trains, the length will be 4. I'll get indexes 1, 2, and 3, right, because we'll skip that none. So we can print the self.trains at index of the index dot get time until fully loaded. And then print has an overload. You can change the ending character to a space if you want so that it doesn't go down a line. So this is something we did in last semester just to get things printed out on one line. You could also use like a string join. Might be a fun way to do that too. So you could return the value with the string join rather than printing it. So maybe printing is a little bit ugly here. Should we just say get and return a string join?
Yeah, but I did.
Okay, so we can do that. So let's how about get. So let me comment this out. So this was for the print here. This was for a print. So probably the cleaner, more Python way, right, would be to return a value. So we're going to return a space. That's the string dot join. What do we need to join? We need to join. What was it for item in self dot trains? This is what train dot. Oh, goodness. I'm going to go from slice it from 1 to the end. Right, we can take the list, start at index 1, go to the end here, and I want to take for train in the self planes. We want the train dot get time until fully loaded as a string. So I think we have to specify the string version of that. Right, so we're going to say this is the string interpolation stuff that people love in Python drives me nuts, but we're saying for every train in self-trains, do this thing with it, joined together by a space. Ugh, it's a little bit gross, but I think it works. We'll see. So instead of printing it out, we're just going to return the value. So these like string interpolation stuff is a little bit, list interpolation stuff is a little funny, but it's essentially putting the for loop and then what you're doing in front of it instead of underneath it here. Yeah, I wasn't sure if it would join it or not, because they're not strings. I think sometimes it fails if it's not strings, but it might be. All right, so I'll get the train fully loaded time. We'll do the same for plane fully loaded time. Goodness, go down some lines, please. Get plane fully loaded time. And the beauty here is it's the same thing. We just go for plane in self-planes sliced. And we can probably get rid of that one, right? Okay, so that should be it here. Maybe that works. Let's try it. So we need to get a bunch of lines here. So we need, I don't know, this is the first line, that's for lack of a better term, is an input. A second line is an input. A third line is an input. A fourth line is an input. And a fifth line is an input. And then we'll make a doc equals doc given the second line, the third line, the fourth line, and the fifth line. We could do better. I guess we should call these things better. This is the items per train, right? This is the items per plane. Items per plane. I'm feeling bad now. Here's the train items, and here's the plane items. And we'll just say this first line to ignore. Why not? We'll use that in our variable name because fun like that. Okay, we'll make our doc, and then we will print the doc.get train fully loaded times, and then we'll print doc.get plane fully loaded times. So you give me 5 lines of input, and I'll load them, do all the things, and go. So I should be able to grab all of this input here, run this program, paste it in. Oh, goodness. Let's see. So invalid literal int with base 10 for a space here. Int of item. Oh, did I not? Plain items. Plain items. Should have been fine. Item in plain. Oh, I didn't split it, right? Did I split it? I did, right? We have plain. No. Okay, yep. This is we can't do. So I was trying to loop through plain items directly here. I need to loop through plain items dot split here. Is what I missed. Right? We have to split that plain items string into the individual values. Right? If doing it for item is giving me every character in it, because remember you can do a for loop over strings. So you just get every character. Well, that's okay. Sure. All right, let's try it again. Try it again. Paste it in. Nope, that's the wrong thing to paste. Come on, come back. Get that one there. Paste it in. Oh, didn't quite get the output we were hoping for. Oh, I've got too many new lines here. All right, it's my copy paste is bad. I'm sorry. That's my fault. Boop, 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 boop. There. Try it again. Now let's paste in our 5 lines and hit enter, and we get some output. 25, 36, 3, 65, 50. It worked. Okay, does that make sense what we were tackling here? Just kind of playing with using some of these. Again, you don't need to use the classes here. I think it just helps us break up the what's responsible for what. And again, part of that object-oriented design, like, hey, the transport method should know, right, how many items it needs, how many items it currently has, and when it was full. And then those things sort of belong together, encapsulated in that noun. You didn't need any of it. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund over here at the University of Michigan Dearborn College of Engineering and Computer Science. It was a lot easier. I said it this morning, like without running out of breath somehow. I don't know. I think I can usually say it all at once, but usually I'm like at the very end. So we did. We hit $250 already now have been donated, and they're coming up on Giving Blue Day, where they do like matching funds. So I'm going to pre-give a little bit of what's going to come next, because Twitch doesn't write checks until you hit $100 or more. But for the Giving Blue Day challenge, they're like, if your particular fundraiser, so like the College of Engineering and Computer Science has a fundraiser for a scholarship fund, if that gets the most donations from faculty, it gets matching money or something like that. Or they, like every hour they have different challenges. It's nonsense, but it's entertaining, I guess. All right, so that was Lab 5. Questions, thoughts, concerns? And a little bit bigger of a lab, but we definitely were able to tackle it here in less than an hour. Here, I mean, I know what I'm doing, so I expect things to take you folks at least double what it takes me. But sort of breaking it down step by step, doing that functional decomposition, right? Take a big problem, break it down into smaller problems. Well, how do we load the trains? How do we load the planes? Right? How do we get all the items from this list into the queue of stacks? That sort of thing. Breaking it down, breaking it down, breaking it down. So again, if you had like better input where you were asking for specific things, great. It doesn't need it for right now, right? There's nothing in the requirements that said, please prompt them for, hey, you should enter these number of items here, right? Anyway, it's up to you, perfectly fine. The beauty of it working like this sort of way with no user interaction necessarily, just taking some values in, is I could feed this values separately. There's actually a list of files of different inputs you can give it with expected outputs and all sorts of fun things. There's a lot of cool things you can do that I haven't quite got to yet with the GitHub Classroom tool. You can set it up to do these unit tests where it says, hey, if you give this input, you expect this output. Hey, you want a dad joke? You got it, my friend. Get out my handy dandy pack of dad jokes. What did the duck say when it bought chapstick? Put it on my bill. All right, I like that one. That was pretty solid. Do one more. Why did the Invisible Man turn down the job offer? He just couldn't see himself doing it. All right, I liked that one. It's probably better than the duck one. All right, awesome. Save those for later. So we should talk a little bit about Lab 6 and then the next project. Let's do the project first, and we can get to Lab 6 a little later if we need to. It just needed a couple tweaks with that position wrapper. So the idea is that the list now has positions and nodes. A position knows what list it's part of, and it knows the node that it's referencing. And then you can give a list a position, and it's going to check, hey, is this position part of me? Like, am I the container for it? Am I the list that this belongs to? And then is the node valid? Great. And then I can add before and add after as part of some of those helper functions. So a lot of copy pasting out of the book, but a little bit of tweaking here or there to get the correct wording here, because they use element, we used data, that sort of thing. Not too bad there. So let's go to the next project here. So project 2. Let's load that one up. We need the classroom link here. And I'm sorry, it's been really rough with this international nonsense happening over in Eastern Europe. I lost a good week I lost a good friend over there a week ago Sunday now, and it's just been a long headache. Two of my kids are adopted from Ukraine, and my great-grandfather was Ukrainian, so I've got family over there still as well. So it's been a little rough. So none of the stuff got graded. I apologize. I will get to it. I'm sorry. If you're stressed about it, let me know. I'm happy to go look at it here. But hopefully you did like a little self-evaluation with the rubric and like, okay, if you checked off the boxes, you'll be fine. We should be okay. So we'll do this in 2 weeks from today then. We do before class starts, so we can go over the solution in class. I don't remember the points here. Yeah, 10 points, 10 points. We can do 10 more points here. We should be fine. We'll go more options. All right, so we need the GitHub Classroom link for project 2. 2001, not 2011. Enter 2022. Project 2. Uses our Python template with feedback pull requests. All right, awesome. So please, here's the link, and then submit the feedback pull request URL. So you need a website URL. Got it. And I will work on the rubric after we post it here. So we are going to build a little simulator, essentially, a way for us to kind of experiment and play with this idea. So it's hard to take a concept and actually try it in the real world. It's much easier to say, okay, let's make a model of that concept and play with all sorts of things about it on a computer and say, okay, let me change this, let me change this. So we're going to build a simulator for optimizing our, now we can't use trademarked words here. So we're not a Five Guys burger and fries joint. We're going to be a, how about Four Friends burgers and fries shop. So we sell burgers and we sell fries. That's all we sell. So we get people in and out the door as fast as possible here at our little convenience store here. So the goal is getting people in and out to maximize our profits, because we don't want too long of a line, right? Because then people will walk away, and we want to make sure that people can get through our, probably a drive-through. I think the drive-through is fine for pretending we don't even have like a storefront here. We just have a drive-through. So like every minute or two or three, a new car is going to show up and want to order a bunch of stuff. So the idea here is we need to build the model for how this works, and then we're going to say, okay, how many burgers should I have ready to go in my burger queue? Right, so I can prep a bunch of burgers in the burger queue, so when a car shows up and says, I want 4 burgers, I just take them out of the burger queue and give them to you. Right, essentially one of those, like the slots they throw the burgers in. We'll just keep throwing them down those slots. Hey, my friend Raven, thank you so much for coming along. I appreciate you being here. We've got our amazing friend here hanging out on Twitch with us here. I gotta find my other keyboard here. He's super cool, super positive. It's so cool being out on Twitch and seeing friendly faces, just trying to make the world a better place. So if you got some free time, go hang out with him. He'll definitely put a smile on your face. We all need a smile, because it's been rough. It's been real rough. So, all right. So our burgers, Four Friends Burger and Fries Shop. So the idea here is we want to see what is the right amount of food to have ready to go to get people through the line faster without wasting money. So we're going to have a couple rules around here. So our burgers can't be served more than, we're going to say 10 minutes after they are cooked. I don't know what the real rule is here, but let's just pretend. I'm sure there's some number. So like they will keep burger patties hot at a McDonald's for a certain amount of time before the health department says they should no longer serve them. It's more than 10 minutes. Okay, but they haven't like wrapped up the whole sandwich in the little package here and that sort of. And at some point, if you give someone a 30-minute old sandwich, they're going to think it's gross and not come back. So, relatively fresh. If it's been put in the wrapper within 10 minutes, I'll probably still eat it, and I won't know the difference. So we'll say that. We'll say fries that have been, or fries can't be served after they have been. I'm trying to use the same word, more than. Now, fries can go a little longer here. They'll start to dry out and get a little bit stale. How about 20 minutes? 20 minutes after they are cooked. Okay. The problem with fries, though, if you remember your fast food restaurants, is they go into a big bucket, essentially, a big basket, which we're going to pretend is a stack. Right? When you take a thing of fries out of the oil and you throw it in the fry warming station, ready to serve fries, you put it on top of what was already there. Now, they hopefully will kind of scoop some to one side. We're not going to do that because we just are in and out, in and out, in and out. We're super fast. So they just go right on top. Okay, so we're going to make a stack of fries as they come out of the fryer. Okay, so fries. Let's see. Fries take probably 2 minutes. 2 minutes to cook in the oil, and you can have up to 4 servings of fries cooking at once. Right? Sorry, my chat's on the other wing. Yeah, FIFO fries, first in, first out fries. This is last in, first out fries. Right? You're getting the stuff off the top, so you gotta time it for the freshest fries. Fresh fry. There's a Dr. Seuss book that has some sort of fresh fried fish. So it's Fox and Socks. It's my favorite book. It's fantastic. I'll read it to you guys sometime. So they'll take 2 minutes to cook in the oil. We can have up to 4 servings of fries cooking at once. Okay, we have got like 4 different slots for our fries. We don't do nuggets. We have all 4 fryer baskets dedicated for fries here. Burgers take probably 3 minutes. We're going to say 3 minutes to cook. And you can have up to, let's say, 10 burgers cooking at a time. Okay? Just estimates here. It doesn't necessarily have to make sense here. And if you'd like to tweak some of these things, I'm open to tweaking some of these rules. But start with these and see how it goes. Like, hey, if we want to get a bigger grill so we can cook 20 burgers at a time, sure, we can pretend we can do that. So it doesn't matter too much here. So we have room for up to 8 burgers in the burger queue. Right, that's the little slider that you put the burgers in. Right? Then they just grab them right off the shelf here. They're already done, ready to go. So when you cook a burger, you send it down the chute. It goes up to where the people are at the window, and they can pull it off, put it in a bag, hand it out the window. Pull it off, put it in the bag, throw it out the window. That sort of thing. So we have those. We have room for up to 10 servings of fries in the fry stack. Fry stack. Right? It's a stack of fries. You just put the fries right on top of the other fries, right on top of the other fries, right on top of the other fries. Okay? So if you have too many fries, you're going to be throwing out the old ones, which is a problem. Right? Because you gotta clear the fries to get down to the bottom ones. Otherwise, if they've been in there for more than 20 minutes, it's no good anymore. Okay, so like there's some amount of fries you want to have on hand, and there's some amount we can wait and say, oh, we ran out, we'll go make you some fresh ones here. Okay? So we're going to simulate being open for, we'll say 120 minutes here. And this again, you can tweak as you go. So then for every minute, there is we'll say a 1 in 3 chance a new car pulls into the drive-through queue. Right? Drive-through is a queue, right? First in, first out for drive-throughs. It's not a stack, it's a queue. Okay? Now, we're not great here. We don't have the double ordering windows like McDonald's have. We don't have the pay window. We don't have the cashier, get your food window. We just have one window. So they pull up, they order, they pay, we give them food, they drive off. Next car pulls up, so we only serve one car at a time. So we only serve one car at a time. Okay? Right? That car that pulls in, or vehicle, I guess I should say, because I drive a 11-passenger van, and my family of 8, soon to be 9, we make quite the McDonald's order. And thankfully, they haven't yelled at me yet. They're all so sweet. Like, hey, can you get this with mayo? Can you get this with no burger because my one daughter's vegetarian? Can I get this with no pickles because my son hates pickles? Can I get, like, everything is custom in every order. And I feel so bad, but they're fantastic. Generally, those people are nice. Sometimes, yeah, they're like, can you just pull ahead? Yeah, actually, most of the time they do get it right. Their system is good enough. Like, if as long as it's entered correctly, they'll follow it because it prints out the little tickets back in the kitchen there. And the chefs probably hate us, or the line cooks probably hate us. But like, okay, this one's a no mayo burger, sure. Or this one's an add mayo burger. This one's a no pickles, and they're pretty good at that. Yeah, that's the trick, right? To get it all fresh. So we're going to serve one car at a time. The car will order a random number of burgers and fries. Okay, so if we have what's available, we're going to hand it to them and they're going to drive off, right? So if the food is available, hand it to them and they drive off in 1 minute, right? Essentially, we'll say 1 minute passes. They pull up, they order, we give them the food. If it's ready, we hand it to them. Otherwise, they have to start waiting, right? Any other car that pulls up is also now waiting. So we need to be tracking. So track time a car arrived, time the car's order was placed, the time the car left, which is essentially, how long it took. I guess that's the same thing. So this order was placed and how long it took to serve the order. Because this is what we want to optimize. We want to optimize for the least amount of time they're spending here without wasting money from food, right? Without wasting a lot of burgers, right? If we always had the burger queue full at capacity, we always had the fry stack full at capacity, we could get orders through like this. But we're going to be going through a lot of food, right? So what we need to do is figure out for our costs, right, how this is going to work, okay? So their order then, so their random number of burgers and fries. So we want to say, so let's do 0 to 6 burgers and 0 to, I don't know how many fries we want. We'll do the same thing, 0 to 6 burgers and 0 to 6 fries. Both are different, right? So it's not 6 burgers and 6 fries. It could be like 1 burger and 6 fries, right? So independent randoms here, separate random values. So maybe you want no burgers, or so fries should always be 1. So maybe no burgers, but always at least 1 fry. I think that works a little better here, because that way, if we both got zeros on both orders, then they would order nothing and go away. And that's not good for us. So we'll pretend that doesn't happen. So 0 to 6 burgers, 1 to 6 fries of separate random values. So again, if we have it, great. If we don't have it, no problem. That's fine. So if they order 6 fries, though, we can only have 4 cooking at once, but we can have up to 10 in the stack. So if our stack is empty and they order 6 fries, it takes 2 minutes to cook 4 fries, 2 more minutes to cook 2 more sets of fries, right? So their wait time is going to be 4 minutes for the fries there, right? So depending on how long things take and how many we have at a time, right, will determine how long this takes. Okay, so we're going to, we'll say 50 cents per fry served and $1 per burger served. So then, we go with profit, because we also want to track losses here. So this is profit. So then spoiled or wasted fries cost us 50 cents. So like we buy them for 50 cents, we sell them for $1. So if we threw out the fries because they were too old to serve, we lost the 50 cents that we spent on it. We're going to assume the labor time doesn't matter, right? Because it's not exactly how economics works, but it's hard to simulate everything. Promise, it's a little hard. So wasted fries cost us 50 cents and wasted burgers cost us $1. We'll do the same thing. So we'll say the burger costs $1 for the raw ingredients. We sell it for $2. So we make $1 profit. We make in profit. Does that make sense? So whichever way you want to work that here. So what we want to do is we want to optimize for making the most amount of money. Is essentially the classic capitalist problem. If it involves a lot of waste, as long as we're making the most amount of money, we probably don't care. Let's be honest, right? If we have to throw out 6 fries every hour because we didn't serve them, but we're making more money because customers don't have to wait as long, that's a good thing, right? Yes, I suppose. Sure. So we're going to try the simulator with different values here. So the idea is when simulating, have a set number of burgers that you aim to have in the burger queue, and a set number of fries in the fry stack available to serve. So the idea is like at the start of every minute. So at the start of every minute here, see if a new car pulls up. Take the front car's order. Start cooking food if we've determined we need to, right? So this idea, we have the set number that we want to have in the burger queue and the fry stack. We also have the orders we need to fulfill, right? So what we're trying to figure out here is how many do we need to have on hand, essentially? Because if we have nothing ever, we always make it fresh when they order it here. Hang on. This number's wrong then, because we want that to be less than, because we can cook all the burgers at once, so we want to be able to cook less burgers. Yeah, so let's make this 6 burgers at a time. Let's say they can order up to, let's do up to 8. How about 1 to 8 here? We'll go nuts here, just for fun. So if we order 8 burgers, right, and we don't have any ready to go, it's going to take at least 6 minutes. That's probably a problem. Right? It's sort of what we're trying to force have happen here. And then see if start cooking food if needed, right? And then take items out of the fry stack and burger queue to start filling the order. Right, and then when the car has its full order, it pulls away. The next minute happens. Right, either we're still cooking things, or we serve the next car, or like all those things have to kind of happen in that minute here. So we're seeing what we're cooking, we're seeing what we're adding to the fry stack if it's done cooking. Right, so you can have burgers cooking at different times here too. So you can have 2 burgers at minute 1, you can have 2 burgers at minute 2, and 2 burgers at minute 3. Right? And then minute 4, those 2 burgers put on at minute 1 are done. You can put on 2 more burgers and put 2 in the burger queue. So you could kind of rotate how many you have at a time on there as well. You don't have to like start them all at one time and say, same with the fries. You can cook 2 fries now and a minute later cook 2 more fries. So you can kind of figure out what's the right order to put those things in for cooking here. Right? So take items out of the fry stack burger queue to start filling the order. Start cooking food if needed. Right? Either to maintain the ready numbers or to fill an order. Right? If we usually only cook 2 fries at a time, but we got an order for 4 fries, you definitely want to put all 4 in. You don't want to just cook 2, wait a minute, and start cooking 2 more. That sort of thing. So the goal is then we can start changing some of these values here. How many do we have ready, and see, are we making more money or less money? So we should be able to run simulator and see how much profit is made over the 120 minutes with given values for number of burgers ready, and number of fries ready. That makes sense? And again, we could tweak other variables here as well, that sort of thing. But this is probably as complex as we want to get for now. So we got the stack of fries, and we got the queue of burgers that we're going to use in this optimization problem. Okay? That's the goal. So that's what we're going to do for the next 2 weeks for our project. We're out of time for Lab 6. I'm sorry. We'll talk about that Thursday and trees. So we'll at least get started on trees. If we have to push it a little bit to next week, we should be fine. Not too big of a deal there. Okay? So I made a note. Oh, following along. Thank you so much for following along. Confused about why all these noises are happening. All right, so we're out of time here. Why don't we call it a day? And we got stuff to work on. Sound good? All right, anybody who's around on Twitch, let's go out and raid a friend here just for fun. Our friend Ashirna does glass blowing, which is super cool. So we'll head over that way here. We put in our raid. Oh, where'd it go? There it is. Ashirna. And we should have a lot of fun there. Okay? All right, folks, you take care. I will see you around, and have fun.